Hello everyone, this is part 2 video on past year NEET questions from the topic electrostatics and capacitors. Those who are looking at this video can also take a look at the part 1 so that you will have continuity of questions. We'll start with a question that has come in the year 2017. The diagrams below show regions of equipotentials. Means they are representing what, if you consider them to be like a surfaces, they are representing what, equipotential surfaces. A positive charge is moved from A to B in each diagram. So in each of these diagrams, diagram 1, 2, 3, 4, we are moving a positive charge from A to B. So here there is a A, here there is a B, A to B. So in each of the cases, we are moving a positive charge from A to B. Now they are giving us 4 options that are talking about the work done. So look at option A. In all the 4 cases, work done is same. Option B, minimum work is required to move the Q in figure 1. Option C, maximum work is required to move Q in figure 2. Option D, maximum work is required to move Q in figure 3. So if you take the charge to be Q, so let us say the charge is what? It's a positive charge. Now in any case, work done will be equal to what? Charge into potential difference through which we have to move the charge, correct? So look at it. In diagram 1, when we move it from A to B, so A is having a potential of 10 volt, B is having a potential of 40 volt. Means in diagram 1, what is the delta V value? It is 40 minus 10, that is 30 volt. In diagram 2, A is again 10 volt, B is again 40 volt. Means here also what is the delta V? 40 minus 10, 30. Diagram 3, A is 10, B is 40. So diagram 3 also delta V is what? 40 minus 10, that is 30. Diagram 4, A is 10 volt, B is 40 volt. So diagram 4 also, right? What is the delta V going to be? 40 minus 10, 30. In all the 4 cases, delta V value is same, which means what? The work in all the 4 cases. In the diagram 1, diagram 2, diagram 3 and diagram 4, all the 4 cases, right? The work will be what? Same. So what is the correct answer for this? Option A. In all the 4 cases, the work done is going to be same. Why? Because we are moving the same charge and delta V is same in all the cases. Now the shape of the equipotential regions or equipotential surfaces may be different, but we have to look at only what is the potential value on the particular surface. Okay, we'll move to the next question. This is a question that is based on the electric dipole, torque acting on the dipole. This has come in the paper 2 of 2016. An electric dipole is placed at an angle of 30 degrees with the electric field. Intensity 2 into 10 power 5 Newton per Coulomb. Means what? They are giving us the electric field value. What is it? 2 into 10 power 5 Newton per Coulomb. And the angle between the dipole and the electric field is what? 30 degrees. It experiences a torque which is equal to 4 Newton meter. Means they are giving us the torque value also. What is it? 4 Newton meter. The charge on the dipole, if the dipole length is 2 centimeter, means we have to find what is the charge on the dipole. They are saying the dipole length of the dipole is what? 2 centimeter. In terms of SI unit, what is it going to be? 2 into 10 power minus 2 meter. So let us say the charge is in coulombs. We are taking everything in the SI system of unit. Then the dipole moment will be what? Charge into the length of the dipole, right? Which is 2 into 10 power minus 2. This is the dipole moment value in the SI unit. Now we know, so if there is a dipole which is making an angle of theta with the electric field, the torque acting on that torque will be equal to what? P cross E in the vector notation. So here we are just looking at the magnitude, right? What will be the magnitude of the torque? P sine theta, right? Cross product, what is the magnitude? P cross E means what is the magnitude? It will be what? P sine theta. So torque is given to us. Everything is in the SI system of unit. Is equal to P. What is P? Q into 2 into 10 power minus 2. We have to keep one thing in mind, that the Q that is going to come from here will be in the SI system of unit, which is coulombs. E is what? E is 2 into 10 power 5 into Sine theta, what is the theta here? 30, right? So sine 30 will be what? Half. So this 2 will be cancelled. 10 power minus 2 into 10 power 5 means what? 10 power 3. So what we have is 4 is equal to q into 2 into 10 power 3. 2 ones are 2 twos are. 10 power 3 will come to the left side, it will go to the denominator. So 2 by 10 power 3, that is q, means it is 2 into 10 power minus 3 in terms of coulombs. 2 in 10 power minus 3 means what? It will be 2 millicoulomb, which is our option B. It's a straightforward question. Just we have to use the torque formula, that's it. And we have to be careful about these units. So if instead of taking the dipole length in terms of conversion value, we would have just taken 2, means we could have got the answer wrong. So we should be careful that the length of the dipole is given in centimeters, while the others are given in the SI system of unit. That conversion we have to be careful. Next we have a question that has come in the NEET paper 2 of 2016. This is based on the modification of the capacitor. A parallel plate capacitor of area A and plate separation D has got a capacitance C, and this is filled with 4 dielectric materials having dielectric constants K1, K2, K3 and K4. We can see here. So this is K1, this is K2, this is K3, this is K4. If a single dielectric material is to be used to have the same capacitance C, then its dielectric constant K is given by, means what they're asking us to tell what is the equivalent dielectric constant. Equivalent dielectric constant means what? So here when we modify the capacitor by introducing some medium in between the capacitor plates, if say for example we have a capacitor, the entire region is filled by just one material of dielectric constant K, then the capacitance will be equal to what? K times A epsilon naught by D. But here it is not like we are filling with one material, we are filling with 4 materials actually, and this is given in a different arrangement. So here one thing is generally we will see the capacitors like this, right? We will keep the plates vertically, but here we must note one thing, that the plates are kept horizontal. If we want to see the way we normally used to write, we have to keep it like this. Okay, so just rotate it. Then what do we have? Look at this. This is our K4. Here we'll have K1, here we'll have K2, here we'll have K3. That is the arrangement, because we are not used to normally seeing the capacitor like this. We are generally used to what? Seeing the capacitors where we keep the plates vertically. Now if you see, this region is like a capacitor. This will be like another capacitor, this is like another capacitor, this is like another capacitor. So if you see, right, the capacitor we'll call it as C1, C2, C3 and C4. C1, C2, C3, right, they are like what? They are a parallel arrangement, and the entire situation is in series with the C4, which means what? To represent it like a combination, right? This is how we are going to look at. So we'll have the capacitors C1, C2, C3, they are parallel. It's like they are connected across, and the entire combination is in series with C4. So look at it. So we'll have a C4, C1 here, C2, C3. So C1, C2, C3, they are like parallel with respect to each other, and the entire setup is in series with the C4. This is the arrangement. Now we have to find what is the equivalent capacitance C. If you are able to express equivalent capacitance, right, from there we will be able to know what is the equivalent dielectric constant. So look at this carefully for each of these capacitors, right? First what we will do is we will try to write down the capacitance values. So we'll start from C1. C1, look at this. What is the area of cross section? A by 3. What is the separation between the plates? This is D by 2. So K1 into area is what? A by 3 epsilon naught by D by 2. So the 2 will go to the numerator, 3 will be in the denominator. What is it? It will be 2 times K1 A epsilon naught by 3D. This is C1. Now C2 and C3 also will have the same values. The only difference will be what? Because for them also area of cross section is same, A by 3, and distance between the plates is what? D by 2. The only difference is in terms of the dielectric constant. So C2 will be what? 2 times K2 A epsilon naught by 3D. C3 will be what? 2 times K3 A epsilon naught by 3D. But what about the C4? In C4 case, area of cross section is A. Separation between the plates is what? D by 2. Which means it will be what? K4, area of cross section is A, epsilon naught divided by D by 2. Which means what? 2 will go to the numerator. 2 times K4 A epsilon naught by D. This is C4. Now C1, C2, C3, they are parallel. What is the equivalent of them? C1 plus C2 plus C3. When capacitors are in parallel, the equivalent capacitance is what? C1 plus C2 plus C3. What is C1 plus C2 plus C3? Just look at them. C1 plus C2 plus C3 means what? So everywhere other than this K1, K2, K3, everything is the same expression. Which means what? Look at this. K1 plus K2 plus K3 into 2 times A epsilon naught by 3D. That is our C1 plus C2 plus C3. Now this is in series with the C4. So this capacitance is basically in series with the C4. Now I'll erase this entire thing because we are done with simplifying of the C1, C2, C3 arrangement. That C1, C2, C3 arrangement we are done simplifying. So the equivalent of that is what? Now the C1, C2, C3, they are totally represented by just one capacitor. What is that value? K1 plus K2 plus K3 into 2 times A epsilon naught by 3D. So this is the equivalent value. Let us call it as what? C dash. C dash is what? K1 plus K2 plus K3 into 2 times A epsilon naught by 3D. Now the overall equivalent capacitance is C, right? Which is equal to what? If you replace the entire medium by one single dielectric, then C will be equal to what? K times A into epsilon naught by D. This K is what we are trying to find. So C4 and C dash equivalent, they are in series. Means what? The overall equivalent capacitance, that is C, 1 by C is equal to what? 1 by C4 plus 1 by C dash. Because they are in series, right? Series means what is the formula? 1 by C equivalent is equal to, if there are many capacitors, 1 by C1 plus 1 by C2 plus 1 by C3, like that, right? So here C4 and C dash are in series. Their equivalent value will be what? Overall capacitance C. So 1 by C is equal to what? 1 by C4 plus 1 by C dash. Now look at this. 1 by C means what? LHS, reciprocal, right? D by K into epsilon naught. That is equal to 1 by C4. 1 by C4 means we have to reciprocate it, which means what? D by 2 K4 A epsilon naught. 1 by C dash means we have to take a reciprocal of that, which will be what? 3D by K1 plus K2 plus K3 into 2 times A epsilon naught. Now we'll just have to simplify this. That's it. So we'll erase this entire thing because this expression is what we have to simplify. From this expression, we will be able to get the relation of K in terms of the K1, K2, K3 and K4. So look at this. On both sides, right, you see that there is a D common in the numerator. We can cancel it off. Same way, A epsilon naught. So left hand side we will be having 1 by K. So 1 by K is equal to what? 1 by 2 times of K4 plus 3 by K1 plus K2 plus K3 into 2. Now we will multiply both sides with 2. So here 2 is cancelled, 2 will be cancelled. So left hand side what we will have? 2 by K, that is equal to what? 1 by K4 plus 3 by K1 plus K2 plus K3. So look at this. What is the correct answer for this? It is option C. So 2 by K is equal to what? I mean, here in the option, they have given 1 by K4 as the second term and 3 by K1 plus K2 plus K3 as the first term. It doesn't matter, right? Because A plus B is always equal to what? B plus A. Now the thing that we have done in this question is, we have tried to represent the arrangement of these different medium inside that capacitor plate region and seen how the combination of capacitors can be achieved. So that is the important. So the main step is what? To identify that C1, C2, C3, they are in parallel and that entire combination is in series with the C4. So once we are able to get that step right, after that it is just writing down the capacitance expressions for each of the capacitors and going on with the simplification of series and parallel arrangement. Next we have another interesting question. This has come in the year 2016, paper 1. Two identical charged spheres suspended from a common point by two massless strings. The length of the strings is what? L. Are initially at a distance d, which is very less in comparison to L. Means what? So we are having two of these charged objects, spheres, which are connected to these massless strings. Length of the strings is what? L. Both are identical. Initially they are at a separation d. Now why they will be at a separation d? Because these are like charges, right? Identical charges. So these charges will be repelling each other. These charge values will be what? Repelling each other. So as a result they will be staying apart. Now we'll see what will be the forces involved here. So if you look at the forces involved, right? Take any charge. Let us say the charge value is Q. Then this is also Q, identical, right? So the repulsive force will be what? KQ square by D square. And this charge, if you take the mass, right, there will be weight. And there will be, of course, the tension force. So this is how we will have the equilibrium of the charge. Any charge you take, there will be three forces: electrostatic repulsion, weight and tension. Because of these three forces, that will be in equilibrium. The charges begin to leak from both the spheres at a constant rate. Means what? This charge is leaking. Leaking means what? Charge value is getting reduced at a constant rate. Means the dq by dt, rate at which the charge is changing, is what? Constant. Now what is going to happen if the charge is leaking? Q value is reduced, right? If the Q is reduced, the electrostatic repulsion force will be reduced. As a result, what is going to happen? These two spheres will keep coming closer and closer. So they will start approaching each other. As a result of this leaking, right, the spheres are approaching each other with a velocity v. The spheres are approaching both of them with a velocity v. Then v varies as a function of distance x between the spheres, because the initial distance between the spheres is what? D. But that is not going to remain constant, right? The distance between them keeps changing. So if you consider at a given instant of time, at a particular moment, the distance between them is x. We have to find how this v is related to the x value. So since we are talking about at a given instant, when already the spheres are approaching each other, right, what we will do is, we will take a certain point of time where the distance between the spheres is already changed. Initially the distance is what? D. Now it will be reduced, and let us say we are looking at a situation where the distance between the spheres is already x. At this time the electrostatic force will be what? KQ square by x square. And we are looking at this particular one of the charges. It will have the weight which will be downwards. Mg is weight downwards. Then there will be that tension along the rope. If you take the angle to be theta here, right, we can resolve the tension into the components. Look at this. T cos theta will be vertically up. T sin theta will be towards the right side. If this forces are balancing, means what? T cos theta is equal to mg and T sin theta is equal to what? KQ square by x square. In this, T is an unknown, or rather unwanted quantity. Correct, because the T is a tension force which is a variable. So what we will do is, from these two expressions, right, let us call it as 1 and 2, we will just do equation 2 by equation 1. Then LHS, right, T will be cancelled. We will have sin theta by cos theta, that is equal to what? KQ square by x square divided by mg, which is what? KQ square by mg into x square. So this is what is sin theta by cos theta, means what? Tan theta. Tan theta will be equal to what? KQ square by mg into x square. So this is the relation we have between the Q value and x. Theta will also be changing here. Theta will not be constant, right? As the spheres are approaching, theta will be changing. But look at this, what will be the theta value? See, this is theta, means the angle inside the triangle is also what? Theta. The angle inside the triangle is also what? Theta. Now, what about the tan theta value? Tan theta will be, this is half, because exactly it will be symmetrically positioned, right? This is what? X by 2 divided by the adjacent side. Adjacent side will be what? It will be root of L square minus x square by 4, because one side is x by 2, hypotenuse is L, right? Means adjacent side will be what? Root of L square minus x square by 4. This will come from the Pythagoras theorem, because base square plus height square is equal to what? Hypotenuse square, right? But the thing is, we are saying that D is very, very small in comparison to L. D is what? The original separation. Means if they are coming even more closer, means the x value also will be very, very small in comparison to L. The value of x will be very, very small in comparison to L, which means what? This adjacent side, we can almost take it as what? L. Again, we have to be clear with the assumption. Why? Because since the D value, the original separation between the spheres, is very small in comparison to L, x also will be very small. So this x square by 4 can be neglected in comparison to L. So as a result, we will take the adjacent side value to be almost close to L. Now this is why we say when theta is very small, right, tan theta will be approximately equal to sin theta. So look at this, what will be the sin theta value here? Opposite, which is x by 2 divided by hypotenuse is what? L. So when theta is very small, tan theta will be approximately equal to what? Sin theta. So the tan theta value we can say is close to what? X by 2L. Now as it is, we will bring and substitute this tan theta in this expression. So here we made one approximation. What is it? Since the x value is very small in comparison to L in that particular triangle, right, we have taken tan theta to be almost same as what? Sin theta. So that is the reason why we are getting tan theta as what? X by 2L. Now tan theta, in place of tan theta, what we will substitute? X by 2L is equal to what? KQ square by mg into x square. We will just rearrange them. So we will bring everything to the left side. Other than q square, let us bring everything to the left side. What we will have? Mg into x cube divided by 2Lk. This is equal to q square. Now the q is changing with respect to time, and so is the x value. Other things are constant. M is a constant, G is a constant, L is a constant, K is a constant, K is the Coulomb's constant, right? Only the x and q values are changing. So let us differentiate on both sides with respect to time. Let us differentiate on both sides with respect to time. But before that, right, since we know that only dq by dt is constant, right, what we will do is we will try to just get the q value. So q square is equal to this much, means what? If you take a square root on both sides, what we will have? Root mg by 2Lk into x to the power of 3 by 2. We have taken a square root on both sides, that is equal to q. So why are we doing it? Because we know that dq by dt will be what? A constant. So we are just trying to get the dq by dt value alone, because if you take a derivative of q square, right, what we will get? If you take a derivative of q square, means we need to understand why are we doing this simplification. So if you take a derivative of q square, what we will get? 2q into dq by dt will come. So here q is unnecessarily coming, that is a variable. So that's the reason why what we are doing, we are not keeping q square value, we are getting q. So q is what? Root of mg by 2Lk into x power 3 by 2. Now we will take a derivative. If I take a derivative, means what we will have? Root mg by 2Lk, that is anyway constant. Derivative of x power 3 by 2 will be what? 3 by 2 into x power half into dx by dt. It's like what? Take a derivative of x power n type is what? N into x power n minus 1 into dx by dt. That is equal to what? Right hand side we will have dq by dt. Now this dq by dt is a constant. That is what is the given information. dq by dt is what? Constant. What is dx by dt? the rate at which this x value is changing. The rate at which the x value is changing, that is what is the v, right? That is what is the v, because the rate at which the x is changing is what? The velocity of the approach for these spheres, which means in this, right, this entire thing is a constant. 3/2 is anyway constant, right hand side is constant. So look at this, x power half into v, that entire thing will be like a constant. We'll take everything to the right side. X power half into v will be constant, which means what? If you take this x power half to the right side, it will become what? X power minus half, because that will go to the denominator, right? X power half will go to denominator, means it will be x power minus half. So what we'll have, v is equal to some constant into x power minus half, which means what? That v is proportional to x to the power of minus half. What is the correct answer? It is option A. So in this, what we did is first we looked at the force balance at that general position. Then using the trigonometric simplification, we were able to get the relation between just q and x. Then we have taken the derivative with respect to time. Since dq by dt is constant, we are able to understand what is the relation between the velocity of approach for the spheres and the x. We'll move on to the next question. This is a question that has come in the year 2015. A parallel plate air capacitor has a capacity C. Means this is what? Capacitance. Distance of separation between the plates is d and potential difference is V applied between the plates. The force of attraction between the plates of the parallel plate capacitor is. So here the region between the capacitor plates, right, is filled with air. That is why they are calling it as what? The parallel plate air capacitor. So it's a straightforward question. So we are having a capacitance value is what? C. And what is the potential applied? V. What is the distance between the plates here? D. Now the field developed, let us call these plates as plate 1 and plate 2. The field developed by plate 1 at the location of plate 2, because one of the plates will be positive, other will be negative. The field developed by plate 1 will be what? Sigma by 2 epsilon naught. Field developed by plate 2 also will be sigma by 2 epsilon naught. That is the reason why when we look at a point in between, right, the field developed by plate 1 will be away from plate 1. Field developed by plate 2 will be towards plate 2, because this is negative. As a result, they both will add. So sigma by 2 epsilon naught plus sigma by 2 epsilon naught, we'll get it as what? Sigma by epsilon naught. That is the field in between the plates. What is the field in between the plates? In the region between the plates, what is it? Sigma by epsilon naught. But when we are finding what is the field at the plate 2, because plate 2 cannot exert field on itself, the field will be what? The field that is developed by just the plate 1. What is that? Sigma by 2 epsilon naught. Sigma means what? Q by A. So what is it? Q by 2A into epsilon naught. This is the field. What is the charge on this plate? Negative, but it will be, value will be what? Q. So the force is equal to what? The charge value. We are just taking the force magnitude. Charge value on the second plate is what? Modulus of minus Q means Q into what is the field at the place? So what is it? Q square by 2A into epsilon naught. So this is the force. But the thing is, we need to express this in terms of the other variables. What are the other variables? Because here the charge is not spoken about. They have given us what? The capacitance value. They have given us the potential that is applied, as well as they have given the distance between the plates. Now look at it. What is it that we can have? Q will be equal to what? C into V, capacitance into voltage, right? So we'll have C square V square by 2A into epsilon naught. But the options are not matching, because in the options, right, we don't have A, because A is a variable that we have introduced, right? A is not there. Then how do we deal with this A? If you look at C, right, what is capacitance value? A into epsilon naught by D. Means in place of A into epsilon naught, what we can substitute? C into D we can substitute. So look at this, C square V square by 2 into, in place of A into epsilon we'll substitute what? C into D. So 1C is cancelled. So what is the final answer? C, only one C will be remaining in the numerator. CV square by 2D. So what is the correct answer for this? It is option D, CV square by 2D. So we are able to get the force expression. Generally what we'll remember, the force acting on any capacitor plate due to the other plate will be what? Q square by 2A epsilon naught. This is the formula that we'll generally remember. But in this question, Q is not given, A is not given. We have to express the value in terms of the others. Next we'll go to a question that has come in the 2015. This is a question relating the electric potential to the field. If potential in a region is expressed as, they are giving us the potential function. What is the potential function? 6xy minus y plus 2yz. This is in volt. Then field in SI unit at the point 1 comma 1 comma 0. See, normally what we know is if we move in a particular direction, we see that the potential change is delta V. We are moving by a length delta L. Then the electric field component in this direction, right? Electric field component in the direction will be given by what? It will be given by minus delta V by delta L. This is what we normally know. But here they are giving us the potential function, and straight away they are asking us to find what is the total electric field. For this we use the gradient relation or the gradient formula. What is the gradient formula? So if we calculate what is the change in potential along the x-axis when the x variable is changing, then the component of electric field along that x-axis will be given by minus dou V by dou x. Dou means what? It is a notation to indicate that here we are looking at the change in the value of V just because of the x. Similarly, we will get the electric field component along the y-axis as what? Minus dou V by dou y. So this dou notation is called as what? The partial derivative notation. So similarly, z will be what? Minus dou V by dou z. So what is this dou V by dou x or dou V by dou y or dou V by dou z? These are called as what? Partial derivatives. So what do we call them as? Partial derivatives. What is the difference between partial derivative and normal derivative? See, generally we will say dv by dx, right? But here we are not saying dv by dx. What we are saying? Dou v by dou x. The difference is when we are doing a partial derivative with respect to x, we are only considering that x is changing. So in this, right, y and z are going to be taken as what? Constants. We are not going to consider y and z as variables. We will consider them as what? Constants. Similarly, if you take the partial derivative with respect to y, means in that case x and z will be treated as what? Constant. If we take the partial derivative with respect to z, x and y are going to be taken as what? Constant, like that. Okay. So now we will go on with the calculation. This is a very standard model of question. Maybe I'm sure during your theory classes you might have practiced this type of questions. It's a straight formula based question. Once you understand what is the formula for the getting of electric field function from the potential, right, we will be able to quickly get the answer. The only thing is it might involve little bit number of steps. So what is it? The overall electric field is given by this minus of dou v by dou x into I cap plus dou v by dou y into j cap, because minus dou v by dou x is what? X component, minus dou v by dou y is what? Y component, minus dou v by dou z is what? Z component. That is why the entire electric field is represented by this expression. Now we have to go and find each of them. So look at this. What will be dou v by dou x? Means we are taking a partial derivative of this entire function 6xy minus y plus 2yz. In this, what we are saying, when you take a partial derivative, only x will be the variable, otherwise y and z are taken as what? Constants. Means this derivative, right, will be equal to what? First term 6 will take as constant, y also will take as constant. So 6 into y What is the derivative of x with respect to x1? Second term, only y is there. Y is a constant, right? So derivative is what? 0. Third term, y and z are there. They are constants. So dou v by dou x is what? 6y. What is dou v by dou x? 6y. Okay. Now we will just keep it. So minus 6y into I cap. So we'll just write down the electric field function parallelly. Next we look at dou v by dou y. What is it? We have to take the partial derivative of the same function, 6xy minus y plus 2yz. So here y is there in the first term, y is there in the second term, y is there in the third term. So look at this first term, 6x is like a constant. What is the derivative of y with respect to y? 1. Second, derivative of y with respect to y? 1. Third, 2z is a constant. Derivative of y with respect to y is what? 1. So totally what is it? 6x minus 1 plus 2z. This is our dou v by dou y. So look at this, what is it? 6x minus 1 plus 2z into j cap. Okay, now we look at the last one. What is it? Dou v by dou z. So which is what? The partial derivative of the entire function, 6xy minus y plus 2yz. In this, xy is a constant because only variable will be what? Z. This is also constant. So 0 minus 0. Here 2y into derivative of z is what? 1. So the value is what? 2y plus 2y into k cap. So this is what is the electric field function. But they are asking us what? Tell the electric field at 1 comma 1 comma 0, means x is 1, y is 1, z is 0. So in this value, right, we just have to substitute. X is what? 1, y is 1. Y1 means it will be what? 6i. X is 1, y is 1, z is 0. Which means what? This is 6 minus 1 is what? 5. This is what? 2 times y. Y is 1. So what is the value? Minus of 6i plus 5j plus 2k. What is the correct answer? It is option D. So this question, right, can be solved if we remember this gradient. So this expression is what we call as the gradient expression. So the electric field will be related to what? The partial derivative terms of the potential function. I think in previous years we got couple of more questions just based on this formula. So it tells that this is an important formula for us. Next we have a question that has come in the 2015 cancelled paper. A parallel plate air capacitor of capacitance C is connected to a cell of EMF V and then disconnected from it. Means what? First we are connecting it across a cell of EMF V. Then what is going to happen? This capacitor is going to get charged. It will be fully charged till the potential on this is equal to what? The potential of the cell. Which means finally the charge value is what? Charge on the capacitor will be what? C into V. Now we are disconnecting it. Remember, when we disconnect a capacitor from a cell or a battery, this is charged. Whatever the charge, so now the capacitor is disconnected. Whatever the charge value, right, is going to remain constant henceforth because we have detached, right? So this is having, say, this side plus Q, this side minus Q. Since we disconnect it from the battery, the charge on the capacitor plates is going to remain constant. Now we have disconnected it. A dielectric slab of dielectric constant K, which can just fill the air gap of the capacitor, means what? We are keeping a dielectric medium in this now. What is the dielectric constant K? Is now inserted in it. Which of the following statements is incorrect? They are asking which of the following statements is actually incorrect. So if we just take a look at these options, right? Option B, what is the option B telling us? The charge on the capacitor plates is not conserved. This is incorrect, right? Why? Because the moment we disconnect the capacitor from the cell, whatever the charge on the capacitor plates, right, This cannot escape anywhere. Means what? The charge is going to remain constant. Option B, they are saying what? The charge in the capacitor plates is not conserved. Means what? That is the incorrect statement. So okay, we got our answer. What is it? Option B is the incorrect one. But we look at the others also. Look at option C. The potential difference between the plates decreases by K times. Potential difference between the plates. See, now the charge is going to remain constant. What is the charge value? C into V. Okay. If you introduce a dielectric medium, the new capacitance will be equal to what? K times the original capacitance. New capacitance will be equal to what? K times the original, because new capacitance, original capacitance is what? So here if you look at the area as A and distance between the plates is D, right? Then what is the original capacitance? A into epsilon naught by D. New capacitance will be what? K times, because we are keeping a dielectric medium. So what do we see? It will be what? K times the original capacitance. Okay, so C dash is equal to what? K times C. Now the capacitance is changing. Now the new potential V dash will be equal to what? Charge. That will be not changing. Divide by new capacitance. So charge is what? C into V. Divided by C dash is what? K times C. So C is cancelled. So V dash is equal to what? V by K. Means the new potential between the plates is what? It is what? 1 by K times of the original potential. So this option C is in fact a true statement, because what it is saying, the potential difference between the plates will be decreasing by K times. So V dash will be equal to what? V by K. Next we look at option D. What is option D talking about? Option D is talking about the energy. What is it? The energy stored in the capacitor decreases by K times. Energy stored in the capacitor decreases by K times. What is the energy formula in terms of charge? Because charge is remaining constant, right? It is easy to work with the charge. What is the original energy? Q square by 2C. New energy is what? Q square by 2C dash. This is the new energy. That is what called as E dash. So Q square by 2 into C dash is what? C dash is K times C, right? Which is what? Q square by 2C is the original energy divided by K. So what do we have? We have the energy is also decreasing by K times. E dash is equal to what? E by K. So the option D is also true. Let us go to option A. Option A is talking about what? The change in the energy. Option A is talking about what? The change in the energy stored in the capacitor. Change means what? We have to look at what is the final energy minus initial energy, right? So look at it. Change of the energy is what? Final energy E dash minus initial energy E. What is it? Q square by 2 into C dash. That is the final energy. Minus initial energy is what? Q square by 2C. So here just now only we have concluded, right? C dash is equal to what? K times of C. So it will be what? Q square by 2kc minus Q square by 2C. Here Q square by 2C is coming out common. Q square by 2C into 1 by K minus 1. So here Q is not given to us. What is given to us is C and V, right? So Q can be expressed as what? Q is equal to CV, right? Means what? C square V square by 2C into 1 by K minus 1. So here 1C is cancelled. What is it? Half CV square into 1 by K minus 1. So what is it? The option A is also true. The change in energy is what? Half CV square into 1 by K minus 1. So A is true, C is true, D is true. What is the one that is incorrect? It is option B. Next we have a theoretical question. Two thin dielectric slabs, constants K1 and K2. So here this is K1, this is K2. They are saying clearly K1 is less than K2. Are inserted between the plates of a parallel plate capacitor as shown in the figure. The variation of the electric field between the plates with the distance d measured from the plate P. So from plate P, we are measuring the distance. So with respect to distance, how the electric field value is going to change? See, remember, normally in the region between the two capacitor plates, what is the electric field value? Electric field value should be equal to what? Sigma by epsilon naught. But when we introduce a dielectric medium, whenever there is a dielectric medium, right, the electric field in the dielectric medium will be what? Less than the electric field in the vacuum or the free space. So it will be what? E dash will be equal to E divided by K. In any dielectric medium, what is the electric field value? It will be equal to what? E in the vacuum or air divided by K. So this K is what is the dielectric constant. K is what? The dielectric constant. Now imagine we are starting from the plate P. Initially there is no dielectric medium. Means what will be the electric field? Sigma by epsilon naught. Once we get into this region, dielectric constant K1, what is going to happen? The field will decrease. Field has to be decreasing. It will not become zero. Like in the diagram D, they are showing it is becoming zero. This is not going to happen. Option A is also not the one. Why? Because initially it is having some value, then they are showing it is increasing. It will not increase, it will in fact decrease. It will be what? Decreasing. Okay. And then it will again come back. So this is the air only, right? It will again come back to normal value. Sigma by epsilon naught. And once it gets into the medium K2, again it has to decrease. So which means, look at this. Here option B is also not correct. Why? Because initially it is, say, sigma by epsilon naught, decreasing. Then air is coming again. So increase, same value. After that we are getting into the medium 2, K2. They are showing increasing. No, again it has to decrease. Once we cross this medium K2, again we are getting into air. So again it will come back to, so this level is what? Sigma by epsilon naught. This is air, this is air, this is air. This is representing K1, this is representing K2. So only option C is able to correctly represent how the electric field will change as we move from P to Q. Here we should notice one more thing. What is it? The K2, look at the relation between them. They are saying what? K1 is less than K2. Let's say K1 is some 20, K2 is some 60. So in medium 1, it will be equal to what? E by 20. In medium 2, what is it? E by 60. So what we'll observe? The E2 value will be lower than the E1. You can see here clearly. This is what? This is the E1 representation, right? This is E2. So E2 value is lower than E1. Why? Because here for the K2 medium, the dielectric constant value is higher. Okay, so what is the correct answer for this? It is option C. Only option C will correctly represent how the electric field will change when we move from left to right, from the plate P towards the plate Q. Next we have a straightforward question. This has come in the 2014. A conducting sphere of radius r is given a charge q. Now understand, when we say conducting sphere, right, for a conductor, charge, any excess charge on the conductor, right, will reside only on the surface. It will not occupy the bulk, which means this conducting sphere, right, is equivalent to a charged spherical shell. The conducting sphere is equivalent to what? Charged spherical shell. The electric potential and the electric field at the center of the sphere are respectively. Now for a spherical shell, right, so if you give a charge will be only on that shell surface. Field inside will be 0. So anywhere inside, it need not be just the center, anywhere inside the shell, field will be what? 0. Same way for a charged conducting sphere, field inside need not be just the center, anywhere the field will be what? 0. Which means they are asking us what? The electric potential and the field. So we are able to see field is what? 0. What about the electric potential? Now for the spherical shell, right, so the result for the conducting sphere is going to be same as the spherical shell. For a spherical shell, what is the potential on the surface? For a spherical shell, potential on the surface will be, it will be kq by r, which is equal to q by 4 pi epsilon naught into r. This is the potential on surface. When we move from potential to inside, the electric field is 0. So when the electric field is 0, right, the potential will not be changing. So when you take a path, let's say we are taking a path from here to center. In this particular path, electric field is not there. If the electric field is not there, means the potential will not be changing. Means whatever the potential on the surface, at each and every point inside the spherical shell, need not be just the center, at each and every point inside, electric potential is going to be same as the potential on the surface. What is it? Q by 4 pi epsilon naught into r. Now same result will be for the conducting sphere also. At each and every point inside, need not be just the center. Center also the same value, but at each and every point, electric potential in that conducting sphere will be constant. What is it? The value will be same as the electric potential on the surface. So potential will be what? Q by 4 pi epsilon naught into r. So they are asking what is the electric potential and the field at the center of the sphere. So potential has to be represented first. Potential is what? Q by 4 pi epsilon naught into r. What is the field? 0. So look at this. Potential is Q by 4 pi epsilon naught into r. And what about the field? Field will be 0. So we have to remember this one. The behavior of a conducting sphere, which will hold the charge on that surface alone, will be same as the behavior of a charged spherical shell. For a non-conducting sphere, it will be different, because for a non-conducting sphere, right, we will have electric field inside the sphere, and potential also will not be constant throughout. Maybe we may have some questions on that. At that time we will look at those expressions. Next, look at it. This is another question. This has come in the 2014. Another question based on the relation between electric potential and field. In a region, the potential is represented. So they are giving us the potential function. What is it? 6x minus 8xy minus 8y plus 6yz, where V is in volt, x, y, z are in meters. Means everything is thankfully in the SI system. The electric force experienced by a charge of 2 coulombs situated at the point 1, 1, 1. Means we have to find what is the force acting on the 2 coulomb charge, which is located at the point 1, 1, 1. See, how do you find force acting on the charge? If you know what is the electric field at the location 1, 1. If you know the electric field, means force acting on the charge will be equal to what? Q times electric field. Force acting on the charge will be what? Q times electric field. So our first task is what? To find what is the electric field. What is given to us? Potential function is given to us, correct? They are giving us the potential function. From potential function, how do you find the electric field? Already we have discussed about it in one of the previous question. This we will get by using what? The gradient formula. So gradient formula will involve the partial derivative. So look at this. Dou v by dou x, partial derivative, 6x minus 8xy minus 8y plus 6yz. So when it say partial derivative, only x is taken as the variable, y and z are going to be taken as constants. So look at it. First term is what? 6x, means 6. Second term, 8 and y are going to be taken as constants. Derivative of x is what? 1. Third term, y will be taken as constant. So 8 is a constant, y is a constant. Derivative will be 0. Fourth term, y is constant, z is constant. So what is it? 6 minus 8y. So 6 minus 8y into I cap. So we just keep substituting. Then we will look at dou v by dou y. So we have to take the partial derivative with respect to y. Same, 6x minus 8xy minus 8y plus 6yz. So when you take a partial derivative, means here y means x will be taken as a constant. So first term will be what? 0. Second term will be minus 8x. Third term will be minus 8. Fourth term will be plus 6z. So what is it? 6z minus 8x minus 8 whole into j cap. Then dou v by dou z. for this what? For the function 6x minus 8xy minus 8y plus 6yz. Here only z will be taken as a variable. So what is it? 6x will be a constant, derivative is 0. 8xy is also constant, derivative is 0. 8y is also constant, derivative is 0. The only thing is what? Derivative of 6yz, further it is 6y. So 6y into k cap. So this is what is our gradient term that will be representing the electric field. Now in this what we have to do, they are asking 1 comma 1 comma 1, right? So we simply have to substitute the coordinates. So we have to put x is equal to 1, y is equal to 1 and z is equal to 1. So the first step of the problem is over. We are able to get the electric field function by using the gradient formula. Now the second step is what? To look at what is the actual value. So what will be the actual value? Look at this electric field at 1 comma 1 comma 1, right, is what? Minus 6 minus 8y, right, means what? Y is 1. So 6 minus 8 is what? Minus 2i. Here z is 1, x is also 1. So 6 minus 8 minus 8. What is it? This is minus 8 means minus 16. 6 minus 16 is what? Minus 10. This is 6 into 1. So there is a minus outside, right? So what is it? If you multiply inside means minus into minus plus. Minus into minus plus. Minus into plus is minus. So this is what is our electric field function. Now the force acting on the charge will be what? 2 into electric field, because the charge is coulombs, 2 coulombs. Electric field is what? 2i plus 10j minus 6k. This is the force. What is it? 4i plus 20j minus 12k. This is the force. But they are just asking about the magnitude, right? So here, we are not representing the units because everything is already in the SI system. What is the force magnitude? Root of x component square plus y component square plus z component square. So what is it? So we can say that this is 4 square, we can take out common, 1 will be there, 5 square will be there, there will be a 3 square. So minus 12 the whole square means minus will go off, right? So 5 square is what? 25. 3 square is what? 9. So this is what? 1 plus 9 is 10. 10 plus 25 is what? 35. There is a 4 square, means 4 will come out of the root as it is. 4 root 35. Inside the root we'll have 35. The value is going to be what? In terms of the SI unit, newtons. So what is the force acting on the charge which we are placing at the 1 comma 1 comma 1? It is 4 into root 35 newtons. The correct answer is option D. So this is about the part 2 video, and we'll see in the next part.